Hello again. I wanted to go through this exercise number 34 of 60 on the Chapter 2 homework. This is an interesting one where you are given a raw data set and you have to construct a histogram that accurately reflects that frequency distribution. So what I'm going to do here is, let's look at this problem real quick. It says that you've got a table below. The table can be found using this icon right here. So I went ahead and clicked on this table icon. And we have the data set here. And what these represent are service times for lunches served in a drive-thru at a fast food restaurant. And so we have to construct a histogram that would reflect a frequency distribution that has a lower class limit starting at 70 seconds and with a class width of 40. And you'll notice, however, that in the multiple choice diagrams here, you get to choose the correct one, the correct histogram. Notice that they don't use values like 70, 110, 150, 190, etc. They use what are called the class boundaries. If you remember, class boundaries are, they were created so that you didn't have gaps between classes or between bars of a histogram, and they always go to one more decimal place than the data. Notice that the data is in whole numbers. It has no tenths place, but class boundaries go to the tenths place. They go to that extra decimal place, and they always end with a 5. And so, for instance, since your data, since they are whole numbers, all of your class boundaries will end with 0.5, and so it turns out that the first class boundary would be 0.5 less than 70. It would be 69.5. And then the farthest class boundary to the right would be 0.5 more than the highest class's upper limit. So it would be 269.5. And then you'll notice that if you examine these class boundaries carefully, they skip by 40. They skip by an increment equal to the class width. Class width was 40, and notice that it jumps by 40 each time as you go from one class boundary to the next. Anyway, let's actually get down to looking at the StatCrunch now. I've opened up the data set by clicking on that icon. Now let's go to this little icon here to open StatCrunch. So what I'm going to do is, like usual, I'm going to go to the data menu and I'm going to sort. I'm going to sort and I'm going to select. Now for some reason this column is labeled 137. Maybe that's because there are 137 items in the data set. I'm not sure at this point why it's called that, but okay, I'm not going to ask any questions. Just go ahead and select it, and I'm going to click Compute. And now we have the data sorted from smallest to largest. And so what I'm going to do next is I am going to do something that we haven't done before. I'm going to identify what classes each of those items fall in by using a feature called bin, or creating bins using StatCrunch. If you were watching, what did I just do there? I unmaximized the MyLab screen and so that I can pull up the StatCrunch and that screen side by side. Okay. And so what I'm going to do is, back in StatCrunch, I'm going to go to Data, and this time I'm going to pick a feature called bin. Bin is kind of like classes. You're going to put the data into bins or classes, but when you use the bin feature, and again, let me remind you, that was in the data menu, and it was down below called bin, down here. What I'm going to do is I'm going to select the sorted column, the one I've sorted, and I'm going to use fixed bins that start at the lowest class boundary of 69.5 with a bin width that would be the same as the class width, or 40. Now, my advice to you is, if you're going to do bins, use class boundaries, don't use class limits. So you wouldn't want to start at 70 like the problem suggests here. You would want to start at 69.5, which would be the class boundary for that, the lower boundary for that class. So you won't want to start at 70, you want to start at 69.5, and then you want that width to be the same as the class width, so it would be 40. And so I've gone ahead and put in my starting value and bin width. I want to do it to the sort column that I've already sorted. Now I'm going to compute. And so what it's done in the third column is it's identified how many times a data item shows up in that first class. Notice that 69.5 to 109.5 shows up a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, which means that my frequency for that class is 11. So I'm going to go ahead and add that. I'm going to type some stuff in here. Let me go ahead and put in that first class and its frequency so that I can keep track of it. So its frequency is 11. All right, so next, let's go to the next class, which is 109.5 to 149.5. Whoops, typo. There we go. And this time, let's look at how many times we've got 109.5 to 149.5 appearing in this list. We've got it a total of, well, it starts at 12, it goes all the way down to row 32. So the last item is 20 rows lower than row 12, but you got to count row 12 itself as well. So that would be a total of 21 items that fall within the class 109.5 to 149.5. So the frequency is 21. Okay, and you can go ahead and count that again for yourself. You can count from row 12 all the way down to 32, and you'll discover that there are 21 data items in this class. And again, I want to remind you that these are class boundaries, not class limits. Because, right, they end in 0.5. These are class boundaries. Anyway, let's keep going. Let's look at the next class, which is 149.5 to 189.5. So how many of those are there? Well, this starts in row 33 and goes all the way to row 41. So that would be a total of, well, row 41 is 8 rows lower, plus you got to count row 33 itself. So that would make 9 total items in this class. So the frequency for this class, 149.5 to 189.5, is 9. And let's keep going here. Let's see. Looking at the next one, 189.5 to 229.5, we've got 1, 2, 3, 4, 5, 6. We've got 6 items in that class and 2 in the last one. So our next class of 189.5 to 229.5 is 6, and the last class is a frequency of 2. And let me just go ahead and look at those again one more time. Looks like we've got 1, 2, 3, 4, 5, 6, and 2 of these. So these are our frequencies. Okay, so let's hold that up here. Let me move that back over here. And let's look at which of these accurately reflects this frequency distribution. Frequencies of 11, 21, 9, 6, and 2. 11, 21, 9, 6, and 2. I'm leaning towards this one. How about you? I believe it's answer C. Let's check. Hooray! So the histogram, it then asks us, does the histogram appear to be skewed? In other words, do you reach a peak early or late? Does it tend to trail off left of center or right of center? Let's look at this. It looks like the histogram does have a longer right tail because it tapers off for a longer distance off to the right. It has a longer right tail. And so we would say that it is skewed to the right. All right. I hope you found this video helpful. Thank you very much.